Hey, what's up guys? This is Akshay from AS Learning, and today in this video we'll be seeing how TF-IDF scores are calculated with the help of an example. Okay. Now, before moving towards the example, let's understand in short what exactly TF-IDF is. So TF-IDF stands for term frequency, inverse document frequency. It's a combination of these two statistical terms, that is term frequency one term and inverse document frequency another term. Okay, and we'll be multiplying these two terms for getting my value of term frequency and inverse document frequency. Now, what is term frequency? Term frequency stands for how frequently a term occurs in a document. Okay, and inverse document frequency tells whether the term is common or rare in a given document corpus. Now, how it will tell whether a term is common or rare in a given document corpus? With the help of its logarithm formula. Now, let's see what's the formula for TF and IDF. Okay. Now, let's keep the example aside a bit. We'll just study the formula first. Okay. Now, this first part which you can see is my TF, the occurrence of term in a document divided by total number of words in a document. Now let's say if I want to find the TF value of RAM in my D1. Now this D1 is my document 1. Okay. Now here, how many times a RAM is occurring in D1? 1. And how many words are there in D1? 1, 2, 3, 4, 5. So my TF value of RAM will be 1 upon 5. Okay. Similarly, I can find the TF value for any word with respect to its document. Okay. Now the next term is inverse document frequency. So here you can see that after this multiplication, this log 10, this is my inverse document frequency. So it is the logarithm of total number of documents divided by the number of documents containing that word. So here total number of documents are how much? 3. And how many documents contain the word RAM? 2. So it will be log of 3 divided by 2. Okay, now you're getting an idea of how exactly the formula works. Okay, now let's do the actual calculation. Okay, now yeah, let's do one thing. In our example, what we'll be doing is we'll be calculating the TF-IDF for is with respect to D1, and we'll be calculating the TF-IDF of cricket. Okay, with respect to D2. Okay, now how many times is a term is occurring in document 1? Only one time. So here you can see that here we are getting the 1. And how many total words are there in document 1? So it is 5. So hence 1 by 5. Now multiplied by, we can see that it is log upon 3 by 3. Now how 3 by 3? Now log of how many number of documents are there? We have 3 documents. Okay, and how many documents contain the word is? It is occurring in all the 3 documents. So in this way we are getting this value, and we can see that the value here is 0. Okay, I'll come back to how this 0 plays a role, but let's first understand the how to calculate this scores. Okay, so it must be very clear how we calculated the TF-IDF for is with respect to document 1 and how it is 0. Similarly, we'll do it for cricket with respect to document D2. Okay, now in D2, how many times is the word cricket occurring? 1. How many words are there in this D2? 5. Hence we are getting 1 by 5. Okay, then log of total number of documents is 3 only, and how many documents contain the word cricket? 1. Hence we are getting a score of 0.095. Now you know that 0.095 is more than 0. Hence cricket is more relevant to D2. Okay, and is, because the score is 0, is not so relevant to D1. Okay, now this is the beauty of TF-IDF. Generally what happens is words like is, the, okay, they have a lot of occurrence. Okay, because they are articles and we need it for uh, grammatical sentence creation. Okay, now because their occurrence is larger, hence the TF is always high. Okay, now but those words are not very important words. Okay, those words don't signify what the document is about. Okay, so hence we want an another parameter which would suppress out their importance, right? है ना? So hence we have the another parameter of logarithm of total number of documents divided by the number of documents in which that word is occurring. Now understand how this term is actually working. Okay, so the we have the total number of documents and we are calculating that the total number of documents in which that word is occurring. Now because is the their occurrence will be very high, hence this value, the denominator of that thing will be larger. Okay, it will be very close to the total number of document. Now because it is very close to the total number of document, that value will be very close to 1. Okay, it won't be a large value. This value which we are seeing, it won't be a large value for terms like is the, it will always be a value somewhat larger than 1, not a very big value. And if we see what the logarithm graph is, now see here, if we see the log 10 graph, see here, if we see the log 10 graph here, now what log 10 does is whenever the value in the x is, let's say, in this range, okay, है ना, whenever this value is in this range, you get a very low value. Why they have picked logarithm? Here we can say very beautifully we can try to understand this. Now let's say for words like cricket or very unique words like Virat Kohli, the value of x will be larger. Okay, now because this value of x will be larger, we'll be getting a larger value here. Okay, and because for words like is and the value is less, hence we will be getting a value very close to 0. It makes the importance very close to 0, and hence we see that for word of cricket we had a larger value, but for word of is we had a lower value. That is the purpose of logarithm. That is the only reason they are using log. Okay, for suppressing out the huge occurrences of words like is the okay. Then apart from this we have a sample Python code, so not a big deal. You can import it from feature extraction module of sklearn. Okay, you can straight away use TF vectorizer, or you can use a count vectorizer plus a TF-IDF transformer, so you can use those combinations also. Okay, I'll recommend you go to the sklearn's page and study its different hyperparameters. Okay, there is a lot which is there in the hyperparameters, and you can tweak your TF-IDF scores accordingly. Okay, so in this way what we learned here is we understood how to calculate TF-IDF for any set of examples. So in interviews generally it is asked, like they generally give sentences and they tell you to calculate the TF-IDF scores. So we saw it, we also saw the Python code, we saw what the main gist of TF-IDF is, how it gives lower importance to words like is the and gives higher importance to unique words like cricket, Virat Kohli, and these kind of words. Okay, now here also in TF-IDF we have some drawbacks. Okay, let's say when we use words like cricket, okay, and let's say if I used a similar word, now synonym for cricket, let's say cricket is a sport. Okay, so let's say badminton. Okay, now okay, wait, I'll give you a better example. Let's say if we had a document of uh, Pink Villa articles and Times of India articles. Now we know Pink Villa is focused more on celebrities, movies and all. So when I'll be finding the TF-IDF scores for celebrity and movies, the score will be high for Pink Villa and low for Times of India. Now when we say now, but in those let's say for example, if in those Pinkville article only the word cinema is used, okay, now when you calculate a TF-IDF score for cinema, you will get a high score. But if you use the word movies, but the although they have used a synonym of that word, but the word movie itself is not occurring. Hence the score will be, it won't justify, because there is no occurrence, hence the score won't be high. And this is where terms, the importance of periphrases, synonyms, and contextual meaning comes in play. And this is where TF-IDF lacks. And hence then we have better embeddings like word to vec, but embeddings, glove, and transformer based embeddings. Okay, so this is one of the drawback of TF-IDF. Okay, so if you learned something new, I feel just give it a small like, share it with your friends, and do check other videos also on AS learning. And do give a star on my GitHub repo. I keep uploading and keep open sourcing my stuff on GitHub. And stay tuned to AS. Till then, peace out.